So next problem, the wages of a factory's workers are assumed to be normally distributed with mean nu and variance 25. A random sample of 25 workers gives the total wages equal to 1250 units. Test the hypothesis mu is equal to 52 against the alternate hypothesis mu is equal to 49 at 1% level of significance. So given sample size, that is random sample of 25 workers, n is equal to 25, but instead of sample mean they have given total wages of 25 workers. So we know mean, which is equal to total divided by number of items, that is total wages divided by number of workers, that is 1250 divided by 25, that is the sample mean, which is equal to 50. And they have given population variance, that is not standard deviation, they have given variance, that is sigma square they have given. So sigma square is equal to 25, therefore standard deviation, population standard deviation is equal to sigma, that is equal to root sigma square root 25, that is equal to 5, right? Then we have to test the hypothesis population mean, which is equal to 52. So here population mean we are going to take mu is equal to 52 also, right? So the hypothesis, null hypothesis, they have given already. Mu is equal to 52, two-tailed we are using. Mu not equal to mu naught. You can choose left tail also because 49 is less than 52, right? So level of significance 1%. So test statistics x bar by minus mu by sigma by root 10, substituting the value 50 minus 52 by 5 by root 25, that is 5 by 5, 1. So we will get minus 2. So in this case we are going to take the calculated value modulus z, modulus 2 minus 2, that is equal to 2. Now tabulated value at 1% level, that is equal to 2.58. So now conclusion, calculated value 2 is less than tabulated value 2.58, therefore H naught is accepted. Therefore mu is equal to 52 only, right? Not 59. Next, another method we are using left tail method. So mu less than mu naught. Here the calculated value is same, right, as it is minus 2. Keep minus 2 as it is. If you are taking modulus value, then you have to take the tabulated value also modulus value. Then the hypothesis, so calculated value in that case greater than the tabulated value, right? Note that whenever you are using left tail, keep if you are having minus value, keep as it is, right? That is easy. So so you will not get confused, right? 1% level. So you are taking z is equal to minus 2 as it is, right? Whenever you are using left tail test, right? Then tabulated value you are taking minus value only, minus 1.28. Compare the calculated and tabulated. Calculated is less than tabulated, therefore H naught is accepted. So mu is equal to 52 and not 49, right? Next problem, a sample of 450 items is taken from a population whose standard deviation is 20, right? The mean of the sample is 30. So a sample of 450 items is taken from the population. So sample size 450, population whose standard deviation, population standard deviation 20, sample mean is 30, right? Test whether the sample has come from the population with mean. Population mean is 29. I'll say calculate 95% confidence limit for the population mean. Given sample size n is equal to 450 and sample mean x bar is equal to 30, population mean mu is equal to 20 and population standard deviation sigma is equal to 20, right? So null hypothesis, there is no significant difference we are taking, so mu is equal to 29, right? We are using two-tailed mu not equal to mu naught alternate hypothesis. So level of significance we are taking 5%. So test statistics z is equal to x bar minus mu by sigma by root 10, 30 minus 29 by 20 by root 450. So you will get 1.0607. So calculated z is equal to 1.0607 and tabulated value of Z at 5% level 1.96. Conclusion: comparing calculated value which is less than the tabulated value, therefore H0 is accepted. So there is no significant difference. Mu is equal to 29 only, right? So 95% confidence limit, we are going to find formula is x bar plus or minus Z alpha sigma by root n. So substituting these values, so you will get 30 plus or minus 1.8479. So taking the minus value first, 30 minus 1.8479, that is lower limit, 28.1521. Then taking the plus value, 30 plus 1.8479, that is the upper limit, 31.8479, right? So here the confidence limit for x bar we are taking, but they are asking, I think, mu. If it is mu, you take the formula mu plus or minus Z alpha sigma by root n. That's all, right? So instead of x bar, you are going to use mu, right? That's all. 30 instead of 30, you are using 29, right? Next problem. A sample of 400 observation has mean 95 and standard deviation 12. Could it be a random sample from a population with mean 98? What can be the maximum value of the population mean? So given sample size n is equal to 400, mean, sample mean x bar is equal to 95, sample standard deviation is small s is equal to 12, and population mean, so we are going to check sample from the population with mean 98, so mu is equal to 98. Define null hypothesis, we are taking, the sample is from the population with mean 98, so mu is equal to 98. So we are again we are using the two tail. So alternate hypothesis h1 is equal, so h1 is mu not equal to mu naught. Level of significance 5% level. So test statistics x bar minus mu by, they have given small s, by root n, right? 95 minus 98 divided by 12 divided by root of 400, so you will get minus 5. So calculated value, modulus value, so modulus minus 5 is equal to 5. Then tabulated value at 5% level, we know 1.96. So conclusion, calculated value is greater than the tabulated value, therefore H0 is rejected. So the random sample is not from the population with mean 98, right? Because H0 is rejected, so mu is equal to 98, rejected, right? Now 95% confidence limit, so x bar plus or minus, right, Z alpha s by root n. So 95 plus or minus 1.96, 12 by root 400, so 95 plus or minus 1.176, so 93.824 or 96.176. So the maximum value of population mean is 96.176, minimum value is 93.824, right? Thanks.